This is our question of graph optimize water distribution. Okay, so in this question what we are getting here, this is our place where we have to just distribute our water by these pipelines. This is your pipelines, this is your edge, and you have to distribute water. You have to distribute water through this pipeline. Okay, so how we can distribute this water through all places? Like here we are using this pipeline, here we are using this pipeline, here we are using this pipeline, here we are using this pipeline. Okay, so how we can distribute the water from these pipelines in an optimized manner? It means we have to make a minimum cost. Like if we use 2, then we want to use 4, then we want to use 7, then we have to just traverse the all places. We have to connect all places now, because we have to supply the water in all places. So we have to connect these pipelines with a print like 1 2 to 3 to 4 to 5. So we have to connect all nodes, but in an optimized manner. So what do you feel that what type of algorithm we have to use? We can use a minimum spanning tree. We have to find a minimum spanning tree in this question. Why? What is minimum spanning tree? Minimum spanning tree is the combination permutation of the all nodes, where the all nodes is connected in an optimized manner, in an optimized cost. Like if we connect 1 2 3 4 5, then we have to connect one. We can connect 1 4 2 3 5, but we have to just check out that it will provide a minimum cost or it will provide a minimum cost. We have to compare those cost. We compare those edge sum. Like when we take 1 2, then we take a weight 2. When we are connected 2 to 3, then we take a weight 4. So we have to just find out the sum of all edge, and here we have to find the sum of all edge, and we compare the both edge, both which is optimized, which have minimum cost, which have a minimum cost. It's called a minimum spanning tree. So we compare both the edge sum. The minimum edge sum is called a minimum spanning tree. Okay, so we just correct the all edges. So this is the same to same algo we have to apply here. We have to find a minimum spanning tree, and this is your answer. And so each sum of the minimum spanning tree will be our answer. Okay, so but there are one constraints. But there are one constraints. Oh, sorry. But there are one constraints is given in this question, which is like you can dig your own wells. You can dig your own wells. It means you can dig your own wells here. 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 You can take water from there. You can take water from there. You can take water from there. You can take water from there by creating your own digs. But it takes some cost. Like it takes 8 cost. It takes 9 cost. It takes 11 cost. It takes 12 cost. It takes 13 cost. So it have own cost to dig a well. So how we can so at this condition how we can find a minimum spanning tree? So we can find a minimum spanning tree. We have to update the graph according to this condition. Like initially we have only 1 2 3 4 5 places, and we have to distribute the water. But at now we have another condition. The condition is like we have extra condition, like we can dig your own wells. Okay, so this is our extra condition. So we have to update our graph according to this condition. How we can update? We have to just put a common vertex. We have to put a common vertex. Okay, so what I'm saying, we have to put a common vertex, and like if we take a common vertex as a 0, and we make this common vertex. Okay, we make this common vertex. Okay, we make this common vertex to everywhere, like here, okay, and this vertex put us some weight, like weight 8, this weight 9, this weight 10, this weight 11, and this weight. So now this graph is updated with another edges, and then we have to apply minimum spanning tree. Then we have to apply minimum spanning tree. So then we have to apply minimum spanning tree. Because we have to find those edges which provide a overall connection. Okay, so we want to connect 1 with 0, 0 with 2, 2 with 3, 3 with 4, 4 with 5. Okay, so we have to supply the water at everywhere, and we can use 0. We can use from 0, and we have to connect this 1 2 3 4 5. Okay, so how we can solve this question? We use minimum disjoint. we can use a disjoint theory. We can use disjoint theory, union disjoint theory, where we are make a parent, and we overlap the two sets according to its pairs, according to its condition. Okay, like we are using, ratherly we are using rank, but here we are not using rank method. We are using the normal union disjoint method. Okay, and union disjoint method. In the previous video, you have to watch the video so you can understand the solution. Okay, so I expect from you that you watch the video of union disjoint theory. Okay, so now I'm going to code it this problem. Okay, so I'm going to code this question. So this is our code. Okay, so what you have to do initially, we have to just add. What we have to do, we have to just add a graph like int I equal to 0 and I less than walls dot size I plus plus, and then we have to just add pipes dot push back. Okay, pipes dot push back 0 comma I plus 1 comma walls of I Okay, and then what you have to do, what we are taking, we are just creating a common 0 with all nodes. It means we have to provide a edge from 0 to 1, 0 to 2, 0 to 3. What I'm saying, we have to connect 0 to 1, 0 to 2, 0 to 3, 0 to 4. Okay, what I'm saying, so what I'm saying is, we have to connect 0 to 1, 0 to 2, 0 to 3, 0 to 4. So we are putting 0 to 1, 0 to 2, 0 to 3, 0 to 4, 0 to 4. Okay, so this is our waves dot size. Okay, so after that, what we have to do, we have to just go and take int min cost. What we have to do, we have to just go, and then we have to do what we have to do, we have to sort pipes dot begin. We have to sort the pipes dot begin, comma, from where, pipes dot end. Okay, pipes dot end, comma, we take vector and int and a comma, we take vector int and v. Okay, after that, what we have to do, we have to just go and return a2 less than b2, a2 less than b2, and put a comma, and then put this curly braces and then close. Okay, so what we are doing here, we are just go and we just we have to just sort this function. Okay, so we just take a pipes dot begin, comma, pipes dot end, and then we put a vector int and a, vector int and v. Okay, after that, we are going to return this function. Okay, we are going to return this function. Okay, we are a2 less than b2, okay, so initially you have to put this comma. Okay, so our condition is good. Okay, so after that, what we have to do, after that sorting, because we have to sort the edge now in the Kruskal algorithm, what we are doing, we have to sort the edge. You have to watch the Kruskal algorithm so that you understand easily. You have to go and watch the Kruskal algorithm for int equal to 0 and I less than or equal n, I plus plus, and after that, what we have to do, we have to just parent, parent method, I hope. Initially we have to make a parent of 1 2 3 2 and 2 and initially, and then what we have to do, we have to take a cost. We have to take a cost equal to 0, and after that what we have to do, we have to manage the parents theory. We have to manage a parent theory, like what, we have to just take, initially we have to just take form for, we have to take a for, we have to take a for vector int and e. We have to take all edges, we have to take all edges in the same pipes. We have to take all edges in pipes. After that what we have to do, we have to just find out our int u equal to e0. We have to find int u, int v, sorry, we have to find out int u0, e0, and then we have to find int e1, then we have to find int, this is our int e1, ub, this is your int w, this is your int w, and which is e2. Okay, after that what we do, we have to just find out print p1, which tells our parent one. Okay, find parent, find pr. In this find pr, what we have to do, we have to just put u. In p2 we have to just take find parent b, and then we just call it. Okay, after that what we have to do, if p1 is not equal to p2, then we have to, what we have to do, we have to just take parent of p1 equal to p2. If both parents are equal, then what we have to do, we have to just cost. If the parent is not equal, then we have to not edge it. It means if the parent of both are not equal, then we have to merge it. Now what I'm saying, if the 1 and 2 is set, and second set is 3 and 4. If 4 is not belonging from that set, if the parent of 4 is 3 and the parent of 2 is 1, so the both parent is not same, so we have to merge this edge. But somewhere if the 4 is here and here also 4, then the parent of 4 is 1 and also the parent of sorry, here. So what I'm saying is, like if this is 1, this is 2, and also this is 1, this is 3. So if we want to merge this 3 with 2, then what we are doing, we just find out what is the parent of 2. So here the parent of 2 is 1 and the parent of 3 is 1. So we can't merge it because this is the same set. This is the same set. So here what we are doing here, we are doing same thing here. What we are doing here is, if we are belonging from the same set, then we can't make a pair. Okay, then we can't make a pair. Okay, then we can't make a pair. Okay, so we have just add the cost. Okay, and after that we have to just return the cost. When we are adding everything, then we have to just return the cost. But we have to make a find par function. So how we can find the parent? This is a recursive call. I think you know that how we can find the parent. We just go and put int find par, where we take int u, and then we have to just return par u equal to u, and comma, if it means pr, if this is equal to u, then we have to do what we have to do. We have to just take par of u equal to find par of par u. Okay, so this is our recursive call. Like if we put u here, then the call is equal to u, and then we just return par u equal to find par u. It means he just want our parent, like it call the recursive call. Okay, it make the call a recursive call. Like if pr equal to u, then this is not, it means this is on parent. What I'm saying, if we want parent of 1, of 2 and 3. If the parent of this set is 3, then one call this parent its parent, and the parent of 1 is 2, and then 2 call his parent and its parent of 3, it will return the 3. Okay, so the parent of 1 is 3 and the parent of 2 is 3 and the parent of 3 is on 3. Okay, so this condition will true here. Okay, so this is our condition. Okay, one second. So we have to just erase this. Okay, so this is our question. We're going to run it. What we are getting error at the point of return. Return PRRU is not equal to U at 11 if U is not equal to U. Oh, sorry. Here we are creating a mistakes. Like what mistake? If PRRU equal to U, then what we are not returning U. Okay. We have to just put U here. After that we have to put here. So we have to just run this program. We are getting error at page 1, I think. Oh, sorry, we are not running in C. I think we are running it Java, I think. This copy code and then we have to just paste it in C++. Okay, so now we have to run it. So well size, okay, so there are mistake in well size. We are not taking right well size. We have to take well size, another error. Oh, push back. So we have to just take a push back, I think. You have to just take this as integer. Then there are also mistake. So now we have to run it. So this is accepted, submit it. So this is submit. So thank you so much for watching this video. Thank you so much.